Okay. So am I in shot here? Or, yeah. Okay. Welcome everybody. My name is Glynn Bird. I'm from IBM. I'm based in Middlesbrough, northeast of England. So I'm across the Pennines today to speak to you. And we're talking about offline first development. And I'll explain what that means. Hopefully by the end of the presentation you'll know what that means. So this is me at I was at a conference in Paris last year, and so I'm in a hotel. I check in online, and then I can't print my boarding pass or anything like that. So it's all very modern. I don't need to print my boarding pass because it gets emailed to me, and Google now passes my emails and presents all the information I need on my phone. So I thought, okay, I'll just go and swipe my phone and check in like a modern citizen. So I'm all ready. I've got my QR code there and all the flight details. And when I get to the check-in desk, I open up my phone, and this is what I see. I see the same details as I had before, but we're missing the vital piece of information, which is the QR code, which allows me to check in. And I'm a bit embarrassed at the front of the queue and saying, sorry, I can't make this thing work, and what's going wrong? And it turns out the thing that's wrong is in the top corner there. I've run out of mobile data. So although I did have that image once, Google now decided to throw that image away and to fetch it again from the server. And because I had no mobile data, it didn't work. So I couldn't check in. I had to go off and log into some Wi-Fi. And anyway, obviously I got back. Don't worry. But that's about user experience. That's the vital piece of information that I needed to have offline. Is another example of a bad user experience. This is a mobile application distributed through the App Store, through the Apple App Store, and it's a game that is designed to be played on your own when you're not with anybody else, and it doesn't work if you're offline. It's deliberately built so it doesn't work. So they've designed it so that if you're offline, present this little pop-up saying, sorry, you're not online, so therefore we cannot run. Now, obviously, a mobile application, all of the assets are local, the logic is local, all of the images that it needs are local. So there's no reason at all why it can't run offline, other than maybe it wants to record its stats, how many games are played and how many people, how long you've been playing, and all that sort of metrics that it might want to collect. But that's not my problem. I don't care about that. That's this application's problem. But that's a bad user experience. So we've been able to build, we were talking about this earlier actually, just informally. If you want to build a website that works in a mobile context these days, it's much easier. You pick up from where somebody else left off. You pick up one of the frameworks, you build your HTML, and your desktop site will look okay on an iPad, it'll look okay on a mobile device because it will scale, it can be responsive. As long as you follow the rules of one of these frameworks, Bootstrap being the most popular one, but there's many others out there that you can pick. So that's easy. But it's not just about building a website to be mobile first, to look nice on a mobile device, because most web requests come from mobile devices these days. So you can't really build for a desktop and then think about your mobile devices. You perhaps want to be thinking about your mobile devices first, and then also while you're at it, make sure it looks reasonable on desktop. That would be a reasonable way of looking at it. And those frameworks help you. But what about offline first? How are you dealing with your customers who have intermittent connections, who are not there all of the time? What experience do they get on your website or mobile application when they are either disconnected or partially connected? This is the ultimate offline first application. This is collecting pictures from Pluto. The data is stored on the probe itself and then beamed back to Earth when it can. It takes actually going to take 18 months to spool all that data back to Earth. They need to upgrade their bandwidth, I think, but it's just so that they store the data locally and spool it back to the cloud later on. So we're either online or offline, you would think. And it's pretty easy for your application to tell whether it's online or offline. You've got full signal, you're on the Wi-Fi. That's not the full story. You may appear to be on the Wi-Fi, you may appear to have a mobile connection, but is it actually usable? Is it actually capable of transmitting and receiving data? Sometimes you may be behind some sort of login screen as you are in an airport. You log in for the free Wi-Fi, but if you visit a page, you get bounced to some other page. So mobile applications don't have data connectivity really in a practical sense. Maybe the connection is so swamped by users that they can't, it's not a usable amount of bandwidth. You're connected to the internet, but you haven't got any bandwidth to use. So this is a problem. You can't necessarily tell from the operating system whether you're online or offline. So it's best to assume the worst. Assume that you've only got access to the offline resources and build for it. Build to be disconnected from the server if you can. And this is where things get complicated. So if you were to look for books on distributed computer systems, you would find there would be lots of them, and they've been doing this for decades. It's a very, very hard area of computing, so you might need a little bit of help. If you can build your application so that it works with its local resources only, then your users will get literally 100% uptime experience. They will appear, your application will appear to be working all the time, because it's not relying on the vagaries of the connection. It's not relying on your server being up, or you having put your money in the meter to have a data connection. If you're reading the data locally, then you're up. The benefits of being first are that you can be faster. You're not waiting for data to be transferred between the server and the client and the server. Mobile connections can be poor like that. And you can work offline and online or anywhere in between reliably if you read your local data first and give that user experience to the user, and it saves your battery life. So mobile devices have limited battery storage. My son goes around playing Pokemon Go and he takes this other great big battery with him, a big cable just to be sure. So if we're going to store data locally and not necessarily refer back to the copy of data in the cloud, how can we present that to our users? Because it presents a user experience problem, really. So imagine I'm building, say, a sports score application, and I refresh it and I see the latest scores, and I take it away, and then half an hour later I say, well, I wonder who scored in the first half. So I'll look at my application. It still knows what the last data it had last half an hour ago, but that data is half an hour old. So it should present to you, this is the last data I have, but it's actually 30 minutes out of date, so things may have changed. This was an ongoing game, but it hasn't finished yet. So it could be in the background trying to fetch the latest data, but at least presenting you with the last data it knew about, with the caveat that it's slightly out of date. That still might be useful to you. You might have just wanted to know who scored in the first half, not what's the current score. So it's a user experience problem, really. And some websites, that the user experience they choose to give you is, when you press refresh, is, sorry, I can't connect to the server at the moment, so I'm not even going to show you the data that I had last time. You don't get anything at all. And that's a pretty bad user experience. So there are user interface challenges to this, to presenting all data and showing it in some way that it is out of date. Right, so the difficulty of offline first, really, in terms of your programming of it, is syncing the data. So syncing the data, imagine if you're collecting data offline, so you're building some sort of IoT thing, and you attach it to a train that's going under the Eurotunnel. You've got no Wi-Fi, you've got no internet, so you've got to collect this data. When you get to the other side, you want to stream it to the cloud. That's relatively straightforward. You store data in a file. When you get to the other side, you shove the file onto the cloud, because the data is only changing on one side of the equation. It's only being collected offline on that device and then arriving on the cloud. But some things are a bit more complicated than that. So say your Facebook profile, for instance, or your email account. Things can be changed on both sides of the equation. So I could be posting data to my Facebook page, and other people could be posting data that would appear in my stream. So there's a two-way connection going on, and that syncing of data is much harder than it seems. Data could get, the same piece of data could get modified in two different ways in the two different copies. So in other words, I could go on my web client and mark an email as archived, and then I could on my mobile client mark it as important, say, and then sync the data. Was it archived or was it important, or was it both? Or you've got to decide. Your database or the syncing mechanism has got to be able to retain both copies of the data. So this is where we get to the solutions part, and then we're going to get into some demos. So what I'm going to show to you today is a free open source database called CouchDB. It's part of the Apache Foundation, and it's a NoSQL database. So if you want to put a JSON document into the database, you just throw the document into the database. You don't have to define a schema, so you don't get any migrations. You're talking about taking a day off because you have to do a database migration. If your schema changes, you don't have to tell the database that the schema's changed. You just change the schema, which means you can be much more agile. So CouchDB is built to be a web-based database. It's not hidden behind in the depths of your data center. It's facing the web, and it has an API. So your mobile device can speak directly to the database. So that's unusual, because normally you might have your own logic in the way, but it does mean that it's pretty powerful. It's built for the web. It's an HTTP database, and it does really good replication. So you can replicate a database from the cloud to a mobile device and back, and the data can be modified in the cloud copy and on the mobile copy, and you can sync, and you won't lose any data, even if the same document is modified in different ways on both copies, which is pretty cool. And it's free, so that's cool. And this is how it works in terms of how can that be? How can that even be? Well, it makes it slightly more complicated for you just for straightforward changes. So maybe I create a document representing me. So I might have name, address, phone number, social media contacts and stuff. So a big complex JSON object representing me. And that becomes version 1 of this document. And then I modify it, and maybe I change my name or something. So that becomes version 2 of the document. And then maybe we replicate that data and put one copy on my mobile device. We've got one copy in the cloud. And then 2 people modify it and change something, and we replicate the data again. So effectively 2 version 3s, one on the cloud and one on the mobile device. And when they replicate back, we end up with 2 version 3s. And that's okay. The database says, okay, it's 2 version 3s. It'll pick a winner by arbitrarily, but you can choose algorithmically which one you would like to be the winner. So you could say, actually, I'm going to merge these 2 JSON documents together in some way, according to my own algorithm. Or I'm just going to, in the event of a conflict, I'm just going to create a version 4, which is actually the same as version 2. I'm just going to effectively revert back if it's a conflict. Or I could just say, actually, any changes that happened on the mobile device win over the ones in the cloud. That's up to you, basically. It's the algorithm that you choose to resolve conflicts is up to you. And it's a bit like a Git merge that doesn't succeed automatically, and it says, oh, hang on, someone's changed it like this and someone's changed it like that. What do you want to do about it? And you, in this context, is software. You can algorithmically choose to fix it or not. So the story of CouchDB is that it's an open source project. It's built in Erlang, which is a language built for high concurrency systems like telephone exchanges. And it's open source. It was taken by a startup called Cloudant maybe 5 or 6 years ago. And they modified it to become a big scalable database. They added some search technology, improved the UI a bit, and so on. And then they've open sourced most of that stuff back. I think 90% of that stuff is open source. So when version 2 of CouchDB comes out, which is nearly out, it's like a release candidate 4 at the moment. But when version 2 comes out, it's basically the same as the Cloudant copy. They have the same feature set. Cloudant was bought by IBM, I should say, a couple of years ago. So it's run as a service. But it's basically the same thing. So if you download a CouchDB 2.0, it's almost identical to what we run as cloud and in the cloud as a service. And all we're doing really is operating as a service. You can download the same stuff and run it yourself. So the distributed nature of it is this: that if you put a document in a database, it's not just being written in one server; it's being written in multiple servers. So you get 3 copies of the data, and that cluster of compute can be as big as you like. It can be 3 servers, it can be 300 servers. The more servers you add, the more data you've got, and the more users can access it. So it's a scalable database. So what can we use on the client side to store the data and replicate it to the cloud? So another open source project called PouchDB, which has nothing to do with my company. It was set up just by some developers. It's called PouchDB, and it deliberately sounds like CouchDB because it speaks the same protocol as CouchDB. So it's a database that lives in the browser. So it's a little JavaScript library that you can import into your own web pages, and then you can use its API to store data in the browser on that device. And the data that you store there, you can simply replicate to a CouchDB database in the cloud. And in both directions if you want, or in one direction if you need. So it's free and open source. It's really good. It's a brilliant piece of software. We were talking earlier about making things work on different devices and different browsers and that sort of thing. But it's tested on a variety of browsers. It works on Firefox and Safari and on the mobile versions. And you know, all of these have different in-browser storage mechanisms, but you don't see that. All you see is the same API: create a document, update a document, delete the document. And it stores the data in the same sort of tree mechanism as CouchDB does, so it can replicate data cleanly to and fro. So that's cool. And this is how easy it is to get started with. So we just got one line of JavaScript to say load the library. That's the top line. And then in your own code, you say, I want to create a new PouchDB object called smart meter, and that's it. You've got a database running on your machine. And then if you want to start pushing data into your database, so here we are creating a very simple JSON document that puts a date and a meter reading, say, and it posts into the database. That's it. So it starts being stored.
Hello.
So that's pretty straightforward. There's no under the hood. It might be doing some relatively complicated things, saying, "Oh, I'm on Firefox, the mobile version of Firefox, so I'm going to use this storage engine to store the data." But you don't see that. You just see the post and puts the data. If you want to supply your own IDs, that's fine. Otherwise, it will auto-generate a UUID. But same principle. And if you want that document back, you say, get me that document back, and you'll get you the document that you posted. Very straightforward. The only thing it's added is the revision number, which is the means of tracking versions and making it so that it can be replicated cleanly to CouchDB. And you can say, get me all of the documents in a collection back, which is pretty straightforward. So there's 24 store. The performance hit of many users accessing their own data is small because they're only accessing their own copies of the data on their own devices. You don't have to provide the central server space, if you like, to be able to deal with 1,000 users all doing that query simultaneously. You're distributing the load around the users because they're all dealing with their own data locally. So that's cool too. So how do you query in a NoSQL database that's built like this? Well, you've got a primary index. You can index by the ID field. That's pretty straightforward. You can create MapReduce views. Anyone familiar with MapReduce as a thing? So this is an algorithm built by Google to distribute queries around a distributed computer system, a distributed database. It's a relatively complicated way to get going if you just want to say, find me all the people whose name starts with G, but you can do it using MapReduce. Or there are a couple of search plugins for PouchDB. One of them is called PouchDB Find, and it basically mimics the MongoDB query language. Has anyone used MongoDB here? So MongoDB's query language is you're specifying a query in this form. You're saying, in this case, I'm finding all of the documents where it has a name field called Mario and has a debut field, which is greater than 1990. It's a bit like a SQL query where the selector is the where, and the fields is the select, and the sort is the sort of a SQL query. If you kind of squint a bit, it looks a bit like a SQL query. So it supports this sort of query language. So you're not completely lost in having to do MapReduce views for everything. You can bring your MongoDB knowledge to bear on your local data set. So when you come to replicating, how do you replicate your data set to the cloud? Well, it's a one-liner, basically. You create another PouchDB instance, but this time pointing to a remote URL in the cloud somewhere, and you issue a one-line command which is replicate to it. So that's to say, take my data that's local and replicate it to the cloud. Now, that will do a one-shot replication, copying all the data it needs to the copy in the cloud. If you run it again later, after more data had been added, it would only replicate the documents that had changed. So it's a kind of incremental replication. If you want to replicate bidirectionally, if you want to sync data effectively, data changes up here, come down here, and changes down here, go up there, then that's a one-line command too. You say sync from my database to the remote database. You can also listen to the changes being sent to and fro. So you could update your user interface to say, oh, there's a change arrived from the cloud copy, or and then you could update your user interface to suit. And then you get an event to say it's complete. Or you could just listen to the changes. So you could just sit there listening to the remote changes and update your interface whenever new data arrives. There are plugins for popular. Anyone use any of these frameworks to build their websites? Which one?
Lots of.
Okay. Thank you.
Angular.
Thank you. So there are adapters for plugging into Angular if you like. So that can give you another head start and not starting from scratch. So that's all fine. We've nearly sorted. We've nearly sorted things. What we're going to do is we're going to create some CouchDB or cloud database in the cloud, which has got a data set, and then we're going to make sure that our website stores its data locally, and we sync the data to the cloud. Very straightforward. But how are we going to get our web page to actually work offline? There's no point if it doesn't render offline. Then there's no point storing the data offline, particularly other than speed and battery life. Well, this has been around for years. This is called an application cache. It's been around since HTML5 came along. It's about 5 years old, I think. And it's a means of you specifying in your web page which assets are required to make it run offline. So you just list, I'm going to need the HTML of the homepage, I'm going to need these 3 CSS files, I'm going to need these 2 JavaScript files, I'm going to need these 6 images. Just list them out, and that instructs the browser to aggressively cache those, to pre-fetch them, in fact, and store them locally permanently. So this is, when the second time you load the page, it loads the local copy. So you don't need to, it doesn't need to make any web requests. And your page effectively runs without you being connected. You can switch your Wi-Fi off and it works. So that's really simple to get started. All you do is 2 things. You put a tag in your HTML tag saying manifest, and you put the path of your app cache file. So it's just a text file. And then your app cache file contains, the top line has to be cache manifest in capitals. And the rest of it is just a list of files, a list of paths. There can be URLs on other people's sites, or there can be paths within your site. And it's just a list of assets, and there can be anything. So this is really straightforward to get started with. And it works pretty well, except that most web developers who use this hate it. And the reason they hate it is that change control becomes a bit tricky. So when you release the next version of your site and you need to not aggressively cache this PNG because you've changed it, it becomes a little bit difficult to force the browser to not cache that file anymore. So there's a kind of change control. There are ways around it, but it's a bit ugly, and people don't like it. So basically, the web development community have come up with something different, and this is called service workers. This is a relatively new API that allows you to script requests emanating from the web page. So you can create a service worker, which is a bit like a little daemon running a client side, through which all of your web requests go. So if your page is going off to fetch images, it comes through your service worker. And you can say to in your service worker code, if I get a request for a server-side JPEG, well, fetch it and then cache it, and then return it back to the browser. And then if I get a request for that same thing again, check I've got it cached and return it. So in other words, you can program your own cache to do anything you want, including change control. There is an intention that service workers will be extended to have their own sync protocol to be able to do push messaging from the service to the client, to do other special things like running stuff in the background, like waking up making your website wake up in the middle of the night, fetch new data, and then go back to sleep again. So there's all sorts of crazy things coming with service workers. But the bad news is it's not very well supported. It's not very well supported in terms of browser coverage. This website here is service worker ready. Is a big long website showing you features going this way and browsers going this way, and all the way down Safari is basically grayed out because it's not supported. So so that's bad. So service workers is reckoned to be the next big thing. Unfortunately, it's just not ready. So if today for universal support, then app cache is probably the way forward. One technique people are vouching for is making progressive web apps, they're called. And these are applications that sense the technology they're running on and progressively either enhance or degrade their experience depending on the features that are available. In other words, if they're running on a browser that supports service workers, for instance, they will use service workers and they will cache the resources. If they're working on a browser that doesn't, it'll only work online. And so it's like a progressive enhancement thing. But the aim of a progressive web app is to look like a native app. It's installable on your device and appears as an icon. It's a URL you can share. It should be able to update itself. In other words, it'll go, oh, it should sense, oh, there's another version of myself in the cloud, so I'm going to delete my cached assets, fetch the new ones, and behave like an application would, like an app store update process would. And they should obviously be responsive, like we talked about for HTML. Mobile sites should be. So this URL, if you were to visit it on your phone, you'd have a hard job differentiating it from a native application. It's a Pokemon library, effectively, and you click into these things. It's got a really fast refresh rate. It's using actually Beat locally. If you visit it the second time, it'll still work, whether you're online or offline. So you would never know it's an app or a website. You don't know, the lines are very blurred between the two. It is running in a browser, but you struggle to know, certainly the second time you load it. And that's probably, and this is a progressive web app, so it might not run on, in that way, on IE or Safari or something like that. But on Chrome or Firefox on a mobile device, it should work just great. So, I'm not quite sure what I'm supposed to be saying here. Responsive mobile, yeah. So build your applications to be both responsive and to work offline first, and to be able to be cached offline so that they work offline. And then you've got yourself a full package, or somewhere in between, or at least head in that direction. What if you're anyone building native applications, or are you all web developers? No native. Okay, I'll go quickly over this bit then, because it's of no interest to you. So if you're building native applications, then you can't use PouchDB necessarily, because you're not running a web browser, you're running a native application. But IBM provides free open source libraries that allow you to do the same thing in a native application. Create a data store that you can store locally in an Android or iOS application and sync to the cloud. Same principle, but not web-based. So let's flip to some demos. So this is an example demo. All of these URLs you can follow and try them out yourself. So this is a simple form-based website. So you visit the website for the first time, it caches all the assets. Second time you visit it, it just works. So behaves like an application. But the idea of this thing is that you build up a web form. You say, I want to collect first name, I want to collect last name, I want to collect an email address, and I want a tick box that says, I agree to the terms and conditions. You save that form, and then from then on, it just presents you the form. You fill the form in, and it stores that data in the database, and then blanks the form. And we use this in to say, enter a company form. We had lots of these iPads around in the conference, and everybody filled in the data on it. They weren't connected to the Wi-Fi, so it all worked offline, so that's fine. And then when we got back to the hotel later, we synced up the data from these web pages, all of these 4 or 5 iPads, and they all ended up in the same CouchDB database in the cloud, and everyone was happy. So we could work. Conference Wi-Fi is always terrible. So nice and simple. Another offline first application. These are all my homemade efforts. So in this case, I'm writing Markdown into a web browser, and so I can write documents while I'm on a train where the Wi-Fi is terrible, but I can still recall old documents I've saved previously. I can even retain versions of documents that I've saved previously. Every time I press save, I create a new version, so I can revert back to an old copy if I need to. But basically, I type on the left panel, and the rendered copy appears on the right-hand panel, and it works offline. All the data is stored, and I can back up to a copy in the cloud. Nice and simple. This third example turns it on its head a little bit. So this is like being a Kindle store, but only for ancient not out of print, but out of copyright books. So I've got a set of databases in the cloud, each one representing a Victorian book, basically. And when you visit this web page, first time it loads the catalogue of books, but it doesn't load the contents of the books, because that would be wasteful. I'd be downloading all of the content for all of the books. But it presents you a user interface, and you can opt to say, oh, I want to read Christmas Carol. So you press download, and it syncs the data from the cloud, stores it on your local device, and then you can read it offline, because the web page will render offline, and you'll be able to read quite happily. So the reference data is in the cloud in this case, and you're optionally syncing to the mobile device. And all of this works offline without any hitch. And this is also another offline site. This is my personal homepage. And it works by having, so there's a series of panels here which represent every time I write something or blog about something, whatever it is, I create a new panel. And the way I create a new panel is to put a document in a CouchDB database in the cloud. And then every time somebody visits glynbird.com, they sync the latest data, and it's stored in the web page locally. If they switch their Wi-Fi off, in fact, let's see if we can demonstrate, because no one believes me. Let's stop doing that. How do I get out of this?
Exit. Is it in the top right-hand corner?
Oh yeah, I'm in full screen mode. Okay. Oh yeah. So this is my page. It's a bit scaled up on this resolution. But I should be able to. I can't even see my Wi-Fi thing.
Yeah, it's usually up there.
I've got so little screen real estate. I can't actually switch my Wi-Fi off. I can do it from here. Otherwise, you definitely won't believe me. Networking. Wi-Fi. Turn Wi-Fi off. My Wi-Fi's off, and then I refresh the page. It still works. I can still render the web page. I can even still do queries. I can say, well, find me all the things to do with Redis, and it will filter the result set by only the Redis ones. So it's doing queries on the database, basically. It's always querying the local database. But the important thing is that once viewed, this web page works offline. All of the assets it needs needn't to be fetched from the cloud. They can just be rendered locally. And so effectively, even if I am connected to the internet, I'm saving bandwidth from your web server. I'm saving load on my web server by not having to fetch things that don't need to be fetched. But eventually, it would sync the latest data and then update the user interface. That's the way it works. So, let's see the presentation. So, another example. This is a slightly off-kilter example, but this is saying It doesn't have to be a website. This is a Chrome extension. So Chrome extensions are these things in the top left corner here. So I'm saying I want to create a password manager that you could pull down. So it senses the tab that you're on in Chrome, and it presents an array of passwords that you have defined against that site. So you might be on Twitter, you might have 4 accounts, so it'll say, here are your 4 Twitter accounts. All of that data is stored in PouchDB locally, because these Chrome extensions are actually just web applications, really. So when I pull this down here, that's just a web page, and I'm using a certain HTML framework. I can't remember which one. And these are just HTML elements, but they're effectively loading the data from a PouchDB database that's stored in this sub-browser here. For good measure, I'm also encrypting the data locally too, because it's my passwords. I don't want anyone who can access that PouchDB database to be able to snoop the database and find my cunning plan of how I do my passwords. And this is a nice demo. So this is saying, okay, what if I want to collect data? Let's collect some data offline. So I've got this is a live example. That's where you live. And this is the badge scanner. So let's just, oh, that's me, look. Can you see that? So if this is an offline first badge scanner. So I should be able to present a QR code. So this is a web page, remember. It's using the video capture API or something. It's capturing my screen. And then it captures the video image, passes it into a canvas control that's hidden from you. And then a JavaScript library goes over that canvas control and tries to look for QR codes. If it finds a QR code, it passes it, puts it in a PouchDB database, and then you've got yourself an offline first badge scanner, hopefully. Demos sometimes don't work. Click. And then down there we've got, that was the data on there. I should be able to present another one. And I get data on there. And all that data is being stored in a database. This page works offline. It doesn't actually work on mobile. I couldn't get the thing to work on mobile, but that's just browsers for you. It does work on Chrome and Firefox. But that's pretty cool. And somewhere there's a settings button somewhere which seems to have fallen off the user interface, which allows you to put a URL of a PouchDB database, and then you can sync data to it from. So, and one thing that, just anticipating one of your questions, when I'm creating a database that's just got my data in it, say my password data in it, or my the documents that I've created, when I'm syncing data to the cloud, do they not get mixed up with everybody else's data? The way that we tend to do it in this world is, say, create a database in the cloud for every user on your system. That keeps everybody separate. And it means that I'm syncing with my database, you're syncing with your database, and we can't clash with each other. We have separate authentication credentials and effectively a separate URL that we're syncing with. So that's all fine, except it is a bit of an inconvenience. So if you've got 50,000 users, you end up with 50,000 databases. The security is good because nobody can leak each other's data, but it's actually really difficult to report on, to say, well, how many things have our 50,000 users got? We'll have to do 50,000 queries across our 50,000 databases. That would be a bad thing. So this thing, if you start scaling up massively, is a way around that. This is Cloud and Envoy is a piece of middleware that I had a hand in writing, which looks like CouchDB to the thing that's syncing with it. But what it actually does is store all the data in one database up in the cloud with everybody's data in. But you wouldn't know that. You would think you were running on a one database per user basis. So it's a little bit advanced, but if you get into creating mobile applications and you do have 50,000 users, and it does become a pain, and this is this is the solution to it. Just to shout out, if you're interested in offline first things, if this thing appeals to you, then there's an offline camp. There's a website called offlinefirst.org, which is a sort of independent organization that promotes offline first practices, which you can visit. And they do camps. This is the second one. It's in California in November 4th. If you're interested in going, it looks very nice indeed. What they do is they take a small bunch of developers, maximum of 30, and take them somewhere to the middle of nowhere to talk about offline first issues and do some hackathons and some listen to some talks, but away from the crowds somewhere. So perhaps maybe not literally offline, but somewhere that appears to be offline. So it's like an offline first camp. And it's a rather picturesque setting. And if you'd like to check that out, there's some URLs on there. So that concludes my talk, and I'm opening up for questions. Yes.
So I don't know if you have any statistics or off the top of your head. Do you know roughly the percentage of applications that are offline first now available in app stores?
I don't. So I checked out my Google applications recently and said, look, do they actually work offline? And things like my inbox, my mail application does. I can compose an email. To read my old emails. I can appear to send an email even though I'm not connected. But when I do connect, it will sync and everything will work. So that's a good experience. Things like Twitter, perhaps not. So I can sometimes refreshing it. It'll show me my old timeline, which is an improvement. It used to just be a big white screen saying, I don't know, I'm offline. But I can't compose a tweet and post it later. Or similarly for Instagram and things like that, where it makes sense to be able to, your user experience should be, yes, I'll allow you to post a tweet, I'll allow you to tag it, I'll allow you to geolocate it, I'll allow you to do everything you need with the photo, and I'll post it when I get online again. You shouldn't have to worry, oh no, you're offline, you'll have to do all this again later. So I don't have any statistics for, but it is a growing trend that it's almost like a competitive advantage for your site to be offline. But if you're a web development agency, I used to work for a company that sold websites, and they would say, oh, do you want your website to be responsive? That's another £100 extra if you want it responsive, because it's an add-on feature. Well, do you want your website to be offline? Work offline? Oh, yes, please. Then that, it's relatively trivial for a web designer to add a little bit of markup or a service worker thing, or a manifest. App cache manifest into there, but it brings great value. It's a big show-off value to the customer. So it's a good thing generally. I think that the challenges are it doesn't suit all use cases. So if you're an e-commerce vendor, say, it makes little sense for you to replicate the whole e-commerce catalog to your machine. So it only suits certain use cases where there's user-generated content or where it's beneficial for somebody to have a slice of the data and take it away with them, modify it, take it back again. It suits things like, I was speaking to a customer who worked in the third world, and they had remote electricity generation stations in the middle of nowhere. And they sent service engineers out with service tickets. And when they got to the other end, they had to mark the service ticket done, and that would trigger something back on the server. But there was no connection, so that all the records were wrong because they had to come back into view of a cell tower and then mark it done, and the timestamps were wrong, and all this sort of thing. It would make perfect sense to effectively check out that ticket, take it with them, change it, and then when they got back into view again, to sync that data to the cloud. So it works in developing areas. So it's good, a really good use case, but it depends on how your data is. So. Any other questions? One more question.
So if you're going to use a database on the device for a mobile device, I guess you need to cater for a range of specifications. Is performance in terms of memory an issue, or storage as well? How do you deal with that?
So if PouchDB, for instance, can store different amounts of data depending on which browser it's running in, which device it's running on. And there's a sort of matrix of, some browsers say, oh, you're only allowed 2 megabytes maximum. Some browsers say, we will warn the user when you exceed a certain amount. Or you can run the devices inside of a container. Has anyone heard of Cordova or PhoneGap? It's like a framework for putting your web application into a native application. So it's a native phone application, but with just a web panel in it, effectively. So you could create your web application that's using PouchDB, put it in Cordova, and then distribute it on it. And when you're using it inside Cordova, PouchDB allows you 50% of the disk space of the phone. So kind of storage becomes irrelevant at that point. You're going to have 16 gig of storage or something. When you're getting to that sort of level, it's, then performance is really about bandwidth, probably, syncing 16 gig of data. But generally, small cuts of data is where it's about, really. As I say, it's not really about syncing Amazon's product catalog to you, but it might be about syncing your orders to you, so that you can view all your orders, whether you're online or offline. Viewing the status of the order as you last knew it on your device. That would be a reasonable use case, because the data size is relatively small and fixed to one user. So it's about picking a battle. Okay, well, thank you for your attention, everybody. I hope that made sense if you joined it halfway through. Did you catch the gist of where we were going? Okay, cool.
Brilliant, thank you.
No problem. Thanks very much.
We've got lots of food to eat.